exam going to be on Monday?
Is that? I think so, yeah.
Okay.
Yeah, because today I'm going to cover, yeah, and then next time I'm going to cover, like for 20 minutes I'm going to teach the last thing, and then rest of that we will practice for the exam. Yeah, you are right.
Okay.
It will be on Monday.
And then we come to class on Tuesday?
Yes,
Okay.
we will have class.
Okay.
Okay, so hello everyone. Now, do you have any questions before I start? Oh, good. Okay, so what you see here is whatever we learned in chapter 1. It's just like 2-3 lectures ago. We talked about individual variables, then categorical variables. We looked at some chart and thought that we could use to visualize categorical variables, pie chart, bar graph, and then we talked about quantitative variables. We talked about histogram. We talked about the stem plot, right? And we use these tools to visualize quantitative variables, okay? And we interpreted some of the graphs. Okay, so in this new chapter so far, what did we learn? You tell me from the beginning, from the 2 major things that I talked about and then listed something under it, and then we went through some of it. So,
measuring center the mean, like.
okay, so let me write now. We talked about measures of center. So what are those?
The median.
Median.
And the mean?
Good. Mean. Okay. And then what else? Some key point. I don't want you now to explain to me what was mean, for example.
The X bar mean is the X with the line above it.
X bar. So we show mean with X bar, right? What is the mean itself? If you want to just explain it in a simplest word, in your language.
Taking all.
Is it like average?
Average, right? And then taking all, continue. You can say. Taking all observations and?
Taking all observations and then dividing by the number of observations that there were.
So what we did, mean is the average, correct? So we take all the observations, add them together, we have the summation of them, and divide by the number of individuals, total number of individuals. We get the mean, average, measure of center. So it helps me as a person who wants to see what my students are doing in the class regarding their exam score. I can understand, oh, the average of exam score is this. And for example, a certain person is above average, right? Or I have like 10 students above average, 2 students below average. So this helps me to understand how my students are doing regarding their exam score, right? Oh, so that was me. And then what about median? What is median? I want all of you to think about that and answer my question.
The center of all of the observations?
Center, or what is the other word?
Midpoint.
Midpoint, correct? So center or midpoint of the data set. And then what I was talking about, I said, if, for example, so this is some question I wanted to ask you. What do I do to find median? The first thing that I do to find median or midpoint?
Organize them by the numbers by smallest to largest.
Smallest to the largest, right? So organize all the observations that you have from smallest to the largest. And then midpoint or median stands in the middle of data set, right? So what that means half of the observations are on the right side of the median, half of the observation on the left side of median, right? If a person, their height is the midpoint, the person is standing in the middle, half of people are shorter than this person and half of the people are taller, right? So that was the midpoint. Okay, we show median width. This was X bar. What was this one? That was easy.
Midpoint.
MM, right?
Oh.
M stands for the first letter in median. Okay. So good, very good. I talked about one thing else which was very important. I compared mean and median. I'm asking you because do you remember I had one last question and I said we are going to start this lecture with that last question. In that last question we are going to have all of these key points. What was the main difference between mean and median? It was like fancy word.
Mean is less accurate than median.
Okay, so that was kind of a little bit, we should change it.
Mean is less accurate than
Mean is less accurate than median. Why?
because if there's an outlier, it gets affected, and median doesn't really get affected.
Yes, correct, very good. Right, do you remember that? So what was that fancy word we used? Median is resistant, right? Correct, good. Resistant measure. And mean is not a resistant measure, right? Good, do you remember all of these? Very good, okay. So, these are all we learned in the last lecture. We talked about resistant measure. And we are going to begin our lecture with a question that goes through this, right? But after that, we are going to talk about measures of variability. And then I'm going to talk about one of them, actually two of them, because I'm going to write down quartiles. Q1, Q3. Quartiles are measure of variability. It tells me how spread the data set is. It divides the whole data set to like equal parts. Then I can easily say, okay, 25% of my students are below the quartile 1, 25% above quartile. So this kind of interpretation, this kind of knowledge it gives me. And then the other measure of variability is a standard deviation, which is more common. We show that with S. So I'm going to start with quartiles. Then we may not be able to cover standard deviation today. That's why I said we are going to cover it next time. But I'm going to talk more about quartiles and how we use them. One of the uses is finding IQR interquartile range. We are going to talk about this today. Interquartile range. And then we are going to talk about 5 number summary, and after we learn about 5 number summary, we will be able to visualize the data set using box plot. So as I mentioned, today we are able to cover all these parts. Okay, so I want to again mention that we are talking about quantitative variables. Since last lecture, we are just focusing on quantitative variables. What is the example of quantitative variable? Who didn't talk so far? What's the example of quantitative variable? Just in the classroom. I had so many examples so far. Not so many, too.
Like weight?
Weight, good, right? Weight, height, age, if age is in number of years, right? And then quantitative variables always have unit of measurement, right? Price of houses in America. So we are focusing on quantitative variables, okay? Okay, so now we are going to begin. These are everything I talked about, we are going to cover, and then we are going to actually jump to which one? I mean, while I'm doing that, get together 2 or 3 of you. Do that, because last time I didn't bother you with that, we just moved to the new classroom. Do that, please. I want you to talk together. What are we doing? 2 or 3 of you. Gather together to have a teamwork. Okay, do that. Okay, you are close together, you can just, yeah, 3 of you are good. Yes. You two can work together, okay? Question is this. Consider this data set, calculate mean, calculate median, right? The way you are going to show that on the exam. Very clean, very show step by step of your work. And the next question is something that I want you to discuss to each other as a team. Well, the first question also, okay, start working on that. What's the first step?
Rearrange the data.
Arrange the data, right? Good. From minimum to the maximum. Okay, do it. Even though we don't need to arrange the data for mean, but for the median, you have to do that, right? And then compare your answer. Yes, do that. That's fine. Yeah. Well, actually, keep either 2 decimal or 1 decimal. A step by a step work. Please. First question. Calculate mean, calculate median. you're doing good. Mhm. Well, keep 85, actually 86 to complete. You're around actually 86, yeah. You're doing good. And then explain it. So, why did you choose that? Write down a little. No, second question. Second question.
For this decimal, we're supposed to run it through the
Yeah, I think it
system.
will be 86, right?
86.
Yeah. And then what do you write down after the value you found for mean or median? You should mention that too. Can you mention? Uh-oh, my bad. You cannot. What if you imagine that our student's grade? In that situation, you can mention what comes after that value you find for mean or median. Imagine these are a student's grade in percentage. So now you know what I'm talking about, right? Did you get it? What about the median? Did you come to it? So then explain for question 2, why did you choose that? No, talk to your team member to see what's their opinion, find the best answer and find the best explanation. Everything fine? So what is that thing that I was mentioning about median is?
Outliers.
Mhm. Very good. Number 2. Yeah. Okay. You got it? Everything fine? Yep. Good, you got it? Ask me your question. No question? Okay, so what happens now? So that was my mistake. I should say these are students' grade in percentage. So the first thing that I didn't see most of you do was to writing down the unit of measurement after mean or median, right? So if this is a percentage, after the value you find for mean, you should write down blah blah percentage, right? Correct? And median too, because we are talking about quantitative variables. Okay, so what is the what is the mean? Group 1. What did you get for mean?
52.
52.86 what? Percentage. You got the same? You got the same? Good. So, group 2, what did you get for median?
58%.
58%? Okay, so this was organized, right? So is that correct? 58? 58? Good. 58%. Okay, so starting with group 3. What is your answer for the second question? Let me read it. Suppose that we multiply the last 3 numbers by 5. What effect would this have on the median of the data? What is your answer?
We didn't do that one yet.
Uh-oh. No effect
On the median,
on the median.
it would have an effect. No, it wouldn't have an effect.
Why?
Because it doesn't change what number is in the middle of all the numbers.
Very good. Very right? So what do you think? So what is the what is that?
Resistant to outliers.
Resistant to outliers. Do you get that? Okay. So it doesn't matter if these numbers are bigger value, smaller value, whatever happens to this number, the midpoint is not affected at all, right? If even we have one large number here, the midpoint will maybe shift a little bit to this side. Why? Because now we have two values in middle and the average of them will be median, right? Do you remember? And the average of 58 and 61 is like maybe something like 59, 50, right? Something like that, which is still so close to 58. So that's the reason median doesn't get affected with an outlier. Do you get this? Is this good? Is this clear? Very good. Okay, so let's move to the measure of variability. Measure of variability. There are two important ones: standard deviation, quartiles. Quartiles actually are two, Q1, Q3. Standard deviation is the most common one. We use it a lot. This talks about the spread of data. How for example, a student's exam grade moves in the data set. If I have like 25% of the students who are like top student, or I have like 25% of a student are like failing. So these are giving us idea how the whole distribution of exam score, for example, works, right? Okay, so quartiles. Well, the first thing I can say about quartiles are that quartiles are calculated like median. They are calculated very, very similarly. And also, I can say they are the measure of variability around the median. Around the median. We can say how the data are variable around the midpoint. So how we do that? When I say quartiles are similar to median, means we can calculate them, we can find them the way we find the median, means the first point that we must follow is, the first step that we must follow is to organize the data again, from the minimum to the maximum, right? This is the first step. Organize all the data sets from minimum to the maximum. The second step is to find the midpoint for the data set. So imagine I have 10, 12, 18, 21, 21, 23, 25, 28. And 30. So the first thing I will do to find the midpoint, because I organized it already, right? Now the second step for me is to find the midpoint. Can you tell me the midpoint by just looking at this?
21.
21? Is that correct? Correct?
Yeah.
Right? Everyone? This 21, right? This is the median. So first step, organize the data. Second step, find the midpoint. The third step, make a data set above the mean, make a data set below the mean. So this is very, very easy. You just must follow the step, and then what you do now is find a midpoint for this data set, find a midpoint for this data set. Then you will call the midpoint for this Q1. Then you will call the midpoint for this Q3. That's it. So now you tell me what is Q1, what is Q3 for this example that I have on the board.
Q1 is 15.
15. Help me with that. So what you did?
Are we doing midpoints or?
Midpoint for this.
Yeah. I added 12 and 18 together, which would be 30, and divided that by 2.
So why did you do that? Because these two are the two.
Center points.
Good, very good, right? And then you said Q1 is?
15.
Very good. Correct? Do you get it? So now Q3.
It would be 26.5.
So you did this.
Yeah.
Tell me.
Added 25 and 28 and divided by 2.
Divide by 2, and then you said Q3 is
26.5.
5. Very good. Good? Everything fine? So the only thing that you must pay attention is the thing that you were always paying attention for midpoint. You should see if the data set is even or odd, right? If it was a even data set, see, at first it was an odd data set, right? And we just had one midpoint that was median, right? And then all of a sudden we separated to two data sets. Each of these data sets are even, right? And now we are dealing with two midpoints. And we have to find the average of those, right? So that's it. This is the main point. This is the most difficult step, right? So there are actually lots of good things about quartiles. So I want you to work on this example, and then I have another example. Then we will go through the key point about quartiles. So first, organize the data set. Second, find a midpoint, median. Third, create one data set on the right side of the midpoint, create another data set on the left side of the midpoint, and find the midpoints for those data sets. The data set on the left side gives you Q1, the data set on the right side gives you Q3. Sorry about that. Okay, if you finish it, raise your hand so I can see the results you got. Okay. Yeah, it's too many numbers. you should have 15 observations, right? Don't miss any of them. If you miss any of them, you are going to find a wrong midpoint. So you have 15, which is odd number. You have midpoint here, 7 here, 7. Oh, good. Yeah, so all of them are odd. Very good. Yeah, okay, well, oh, we don't have the next slide yet. Yes. No, okay, so first show these, which is name this. Oh, yeah, I think it's correct. You got it too. So, yeah, just remember it's 15 numbers, right? Means I should have this one. You're doing good. Okay, compare your answer with your neighbor so you know everything is correct. Because I didn't solve this. You're going to solve it. You find it as something. Yeah, compare to make sure if you are correct and I didn't miss anything. You're good too? You found the correct one? Oh. Shall I solve it? Or you just give me the answer? Okay, just to save time, you give me all the organized.
5, 8, 10, 12, 15, 15, 20.
I'm behind.
Oh, I'm sorry. 15, 20, 20, 25, 30, 35, 35, 40, 40, 70.
Good. Okay, so where's the midpoint?
The second one.
This one? Okay, so this is the midpoint. What formula did you use?
The n plus 1 divided by 2.
15 plus 1. 2.
Equal.
It was 16 divided by 2, so it would be 8.
8. Means 8 observation. 1, 2, 3, 4, 5, 6, 7, 8. Good. Correct. Okay, so now the data set on the left side gives us the lower quartile. The data set on the right side gives us the upper quartile. So how many observations do we have here?
7.
7. So I'm going to use the formula n plus 1 divided by 2 equal 1, which is 7 plus 1 divided by 2 equal
4.
4th observation. 1, 2, 3, 4. Correct? This one is
Q1.
Q1. Very good. Okay. think I should again calculate n plus 1 divided by 2.
No, because it's the same amount.
Same, right? They both are 7. 7 here, 7 here. So 1, 2, 3, 4. Am I right? Did you see that? I counted from the number after median. The number after median. 1, 2, 3, 4. This is Q.
3.
Okay, very good. Do you have any question? No? So what we had here, so the whole data set was odd number of observations, had odd number of observations, right? And this data set on the left side, data set on the right side also had odd number of observations. So you didn't have to find two midpoint and calculating their average, right? So it was just a straightforward, right? Okay, so this one. Now you have 16 observations. Well, do you have to go through organizing them? No. So I'm going to save you time and tell you that I just added one number here. So if you can feed it between your data set or rewrite your organized data set and put 24 in the middle, then it will save you lots of time. So I just saw one thing. So now you have 16 observations. This is even data set. So you definitely should start to, see which one you lost, which one of these numbers you lost. Oh, see, you just wrote down once, yeah.
Thank you.
You did the same thing? Yeah, that is good point. Very good. I'm glad you paid attention. So this will be the midpoint and 20 will be 1 midpoint. So this is the end of the
I'm just like, oh, my God. So you would add them to all?
Yeah, and then different for 2.
Okay.
I think, I mean,
Very good. Yes. Yeah, because 20 is 1 big part. Right. Do you get that? Do you see there's something different, right? You should make a decision how to include, which value to include in the data set on the left side, in the data set on the right side. Yes. So the median, the average of 20 and 24.
Well, I think you would use
This
it
is not a location.
get those numbers? Yeah. In the middle.
between these two. So 20 is, yeah, exactly. 20 is before median, 24 is after median, right? Yeah. Yeah, because 24 is between these two, right? Oh, 44 divided by 2 is 22. Alright, okay. Yeah. Okay, so 22 is between 20 and 24, right?
Yeah.
And then 20 becomes,
Okay.
yeah, and 24 plus. Did you get it? Okay.
Who else?
I think maybe I have to check this, right?
So pretty much
Yes.
they both separated, right?
Mm-hmm. Yeah, so just call this parentheses, so we can get out this like that. Yeah, and this one, yeah. And this. Yeah, thank you.
Okay, good. Everyone on the right track?
So, now what happens to 24 is 44. And 44 divided by 2 is 22.
Okay, so I think everyone got this, right? Okay, so tell me. From the minimum, we have
5, 8, 10, 12, 15, 15, 20, 20, 24, 35, 30, 35, 35, 40, 40, and 70.
Okay, so I will use the formula, right? I'm going to say n plus 1 divided by 2. So what should I write down instead of n?
160?
16 plus 1 divided by 2 is
8.5?
8.5, and this is the location of median. So what this means? Median is between observation number.
8
8.
and 9.
Good. Median is between observation. I don't write it completely, but observation number 8 and 9, right? So I'm going to count from the beginning. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 8. This is 9. So what should I do now?
Both of them and divide by 2.
Add them. Divide by 2. What is that?
22.
22 is median, right? So now the data set on the left side of median, because median is 22 between these two, right? The data set on the left side will be from 5 to 20, right? And then the data set on the right side of median will be from 24 to
70.
17. And then what is Q1? Well, actually give me the number of observations you have in this data set.
8.
Okay. M plus 1 divided by 2 is 8 plus 1 divided by 2 is
4.5.
4.5. Well, this example were more tricky. Between 4th,
And 5th.
good, 4th and 5th. Median is between 4th and 5th, right? So I'm going to calculate, what's that, count? 1, 2, 3, 4. This is observation number 4. And then this is observation number 5. Now everything is messy. I'm going to bring this here and say Q1 is equal to,
13.5.
so how did you do that?
12 plus 15 divided by 2.
Which is 13.5, you said?
Yes, that's what I got.
Correct? Everyone?
Yes.
So what about this one? Still we have the same number of observation. 8 plus 1 divided by 2 is 4.5. Median must be between observation 4 and 5. Am I correct?
Yes.
Good? So I'm going to count. 1, 2, 3, 4. This is observation number 4 and this is observation number 5. And then Q3 is equal to
35.
how?
They're both 35.
35 plus 35 divided by 2 is 35. Right? Everything is clear? Is that good? Okay. So, now, this is the moment that I want you to think about it. Write down the answer on your note. I'm going to go around and see what your answer is. So think about that. What is the second quartile? Because I said first quartile, third quartile, so second quartile is missing. If you have your answer, raise your hand. Don't say it loud. Very good. Very good. So now write down the second quartile is blah blah. The name I want. Very good. Well, not related to the previous example. Yes, correct. But you can generally write down your answer. Not relate to. You don't have to relate it to the previous example, right? Very good. Very good. Very good. Anyone else? Do you have it? Can you guess it? No?
The median?
The median, right? So, median. I'm going to start from explaining about median again, then you will understand what's going on. So median was the observation that stands in middle, and 50% of the observation goes on the right side of median. The other 50% stands on the left side of median. That's why median is midpoint. It divides the data set to two equal parts. 50% one side, 50% another side, right? It's a balance point, correct? Quartiles, on the other hand, what they do, they divide the data set to 25% parts. Means 4 parts, that's why there are quartiles. 1 quarter is before the first median, quartile. Another quart, or 1/4, or 25%, is above the third quartile. And then what happens? On the right side of median, to Q3, we have 25% of observations. On the left side of median, to Q1, we have 25% of observations. So you see, there are 4 equal parts, right? So Q1 comes first, the first quartile, then obviously median is again divided the observation between these two quartiles. So median is the second quartile, right? Because median is dividing the observations between Q1 and Q3. 25, 25. And then comes quartile 3, and then we will have 25% above quartile 3. Okay, so in this way I can say, for example, about a student's exam grade, I can say, oh, this student's grade is the top 25% of the grades in my classroom, right? I can say, oh, this student's grade was not good. It's the bottom 25% of the class. If I have the Q1, if I have Q3, if I divide the distribution to 4 equal parts, I can explain the exam grade like that. Right? And then I will explain to a student, if you try this much, if you have this exam score, you will be above median, above Q1, you will become the top 25%, right? So, this is the way we use quartiles. Now, another tricky question. So, think about this too. Do you think quartiles are resistant measure or they are not resistant measure? And why? Write it down on your note and explain why the way I can understand it. The way it's easier for me to understand it. Oops. Okay, who is first? Want to show me? Since you have. Very good. Amazing. You too? Very good. Very, very good. Who else? Very good. So if you have any idea, please write it down. Please write it down. Write down your answer and write down your idea. It doesn't matter if it is correct or not. Still, I want you to write it down. I want you to think about it. Not yet? Okay. That's fine. I mean, as long as you are thinking and thinking that way. Well, I mean, you are still very close. I mean, the idea is there. You just should more think about it to see which one is closer to, which one is more similar to.
Yeah, I was thinking,
And then the one that is similar to, is that resistant or is not resistant? Things like that. You're there. You're almost there. Fine. Okay, continue writing down. So just think about that. Which of the measures that we already talked about is similar to quartiles? And if those measures were, or if that measure were resistant or not. Just think that way, maybe it comes to your mind.
you're very, 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 very close. You could say it more directly. You said, because it is exact same as that one,
Oh,
right?
yeah.
Okay, so anyone else? Do you want to show me what you wrote down?
I'll just switch them around.
Okay. And then you change this one too.
This-
Yeah. Well, you're almost there. You got that.
My mind is
Yeah.
not working on this thing. It's way too early.
Well-
In a couple days.
Well, I mean, you were very good so far. This is a tricky question. This is a very tricky question. You have to relate everything together and remember, and you have to have a fresh mind right now, not tired. Okay, shall we talk about it? So the first thing I said about quartiles was they are calculated similar to median, right? They are still the midpoints, right? So they are still the midpoint. Means if you add any observation, an outlier, for example, to the end of data set, these midpoints will a little bit shift to the right or left, right? The extra observation that comes to the data set doesn't affect the location of midpoints. If it was mean, we would say, yeah, we are adding all of them together and a huge number will all of a sudden increase the summation a lot, right? But midpoint they don't move that much if you add just one extra outlier, right? So quartiles are still the midpoint, are still similar to the median. Median was resistant, right? So quartiles are also resistant measure. Do you get this? Is that clear? Okay, so now we are going to talk about the 5-number summary. So we talked about measure of centers like mean, median. We talked about quartiles that are the measure of variability. And then we are going to get the benefit of some of these. We are going to get the benefit of median. We are going to use quartiles. And then there are 2 observations that we never directly talked about. The minimum observation, the maximum observation. We never talked about them directly because I assume that everyone knows what is the maximum, what is the minimum observation, right? When you order all the observation from minimum to maximum. We are going to use these 5 measures: minimum, maximum, Q1, Q3, and median, which is Q2. We are going to use this, and again, these all help us to divide the data set to 4 equal parts, because all of these are like Q1, Q2, Q3, they are all midpoints, they are all, dividing the data set, right? So we are going to use these 5 important numbers, not just because they are very accurate. We can use them to draw a new graph. We call that box plot. So far, we talked about graph like histogram, a stem plot, and they were all for quantitative variables. And this is a new one. Now, this is new graph that help us to interpret the data set in different way. Okay, so what is that different way? The box plot is going to be like this, using minimum, using Q1, using median, Q3, and max. we have a box in the middle. The first bar shows the first quartile, the second bar shows the median, the third bar shows the third quartile. And then these two smaller bar, which usually we show it with like a point, but this is more pretty. This is the mean, this is the maximum. So imagine you have an x-axis that order all the data, like a student's height, from the minimum to the maximum, right? Then this will be the minimum height on the x graph. You are imagining a x-axis, right? And then this point on the x-axis will be Q1. This point on the x-axis will be median. This point on the x-axis will be Q3. And this point will be the maximum. And then as I divided that, I'm showing that 25% of observation falls from the minimum height to the first quartile of height. Then I'm showing the second 25% of height falls between the first quartile and the median height. And then another 25% of observations means, so how can I say that? I can say if I have 100 students, if I have 100 students, 25 students, their height is between the minimum height and the first quartile. Is that easier now? Is that better now? 25 of students out of 100 students will fall between minimum height to the first quartile height. And then 25 students out of 100 students, their height falls between Q3 and the maximum. But this graph that you see box plot now, it's a symmetric box plot. So I'm talking about the shape, right? Because I talked about shape when I had histogram. I talked about the shape when I had a stem plot. Because both of them were talking about quantitative variables. Now again, I'm talking about shape. Yes, because this is describing the quantitative variables. So how do I see a shape? Symmetric shape. I see it this way. If I can do it properly, I'm not an artist. So, do you remember in a symmetric distribution, median falls in the middle exactly? Mean and median both in a symmetric, do you remember? Falls in the middle exactly. And then if you had right skewed or left skewed, mean is pulled toward the skewness. Do you remember now? We talked about that. And the median is always around the peak, but on the x-axis, right? So this is a symmetric shape. This is in an assumption that everything in the population, in the, for example, 100 students is perfect, like their heights are very symmetric, like we have the same number of people who are between minimum height to quartile, and we have the same number of students between quartile 3 and maximum. This is the assumption that everything is perfect. Okay, so now you answer this question. What percent of the data are between minimum value, means here, to Q3? What percent of the data is between this one and this one? 75%, right? And then now in here you see easily all the observation before median will be 50% of all the observation. On the left side of median we have 50% of observations, right? Good? So in this way, we are dividing the distribution. So now here, I think this will be the last question that we are solving, because if the time, if we have enough time, we can solve this and talk about the last small point. Okay, please do this very fast. Now you are expert. Now you know how to do this. I want you to find the minimum, maximum, midpoint, which is median, quartile 1, quartile 3, because we are talking about 5-number summary, right? So I want a 5-number summary for this data set.
Do you want us to draw the box?
Well, I don't want you to do that right now because this will be very time consuming. But I will show you. I will show you on these slides. Well, maybe I should help you be the organizing the data. But it's too much. Too much help now, right? So now this is easier for you, very easier to give me the 5-number summary. Minimum. Q1. Median. Q3. But I'm not sure about the median. I don't remember the median exact. Okay, median is good, correct. Yeah.
I was thinking it was 64.
65. Well, very nice. How many observations do we have?
Why? Okay.
Total 20? Yeah. 20, right? Okay. Okay, so minimum and maximum are easy. Tell me what's the minimum? 10. What's the maximum?
75.
75. And I think by now everyone got the median.
Yes.
What is that?
32.5.
Everyone?
Yes.
Good? Q1?
27?
13.
Oh, 13.5.
13.5? Right? Okay. What about Q3?
50.
50?
Mm-hmm.
50. Correct. Correct. Very good. Good? We are good? Ah. So, here is the box plot for the time. What was that? Communication time? Commuting time, sorry. Travel time data set from New York. So, this is the data set that shows the minimum. X-axis shows the travel time. Minimum is 10. The first bar is the 13.5 Q1. The next one is median. Then we have Q3, right? 50. And then we have maximum 70, right? 75? Good. And then look, we can show two box plot in one plane. This is the travel time for North Carolina on your book. And then this is what I used for this presentation, right? And then here is the question, what percent of observations traveling between 50 minutes to 75 minutes? What percent of people traveling between 50 minutes to 75 minutes per day?
75?
50 minutes
Oh,
to 75 minutes.
35. No, 25.
What percent? 25%, right? 25. Correct? 25% of people are between the third quartile and the maximum, right? That's the way we will say there are 25% of people in New York who travel between 50 minutes to 75 minutes, right? And then half of people travel less than 32.5 minutes. Half of the people travel less than 32.5 minutes, which is median, right? So this is the box plot. And here's the stem graph for this box plot. And then I made it horizontally, right? And then you will see the shape, but this is a two-peak shape, right? Do you see that? Oh, so, and this is the last thing I wanted you to pay attention. This is the last slide. So, we have a right skewed, we have a symmetry, we have a left skewed distribution, right? So, this is the last that we wanted to look at. Okay, any question? Sorry, I kept you 3 more minutes. Okay, so next time what we are going to talk about, we are going to talk about IQR, interquartile range. We are going to talk about the standard deviation. But please, work on your assignment. You must finish the first homework, first quiz by now. You must start on the second homework and second quiz by now. Correct? Okay. We'll see you next time. Take care. Bring your